We are accustomed to seeing superhero flight as a graceful glide, but physics dictates a harsher reality. When 2 tons of gold titanium alloy move at 1,500 miles per hour, momentum demands they continue in a straight line, unaffected by the path ahead. Forcing that mass to execute a sharp 90-degree turn at Mach 2 requires extreme mechanical intervention. You have to generate 20 to 30 Gs of force to change that trajectory. A traditional fighter jet handles these forces by distributing aerodynamic load across a large surface area, using its wings to manage the physical stress of cutting through the air. The Iron Man suit lacks this surface area. It functions as a humanoid point mass. Lacking wings to spread the stress, a high-speed turn triggers inertial shearing. As the thrusters fire to force a vector change, the raw momentum of the suit tries to rip the airframe forward. The human body was not designed to endure these intersecting forces. A highly trained pilot will experience gravity-induced loss of consciousness, or G-LOC, at 9 to 12 Gs. At 30 Gs, the human skeleton caves in. The spine is crushed, and the mechanical stress shears the armor's connecting joints. Banking around a skyscraper at supersonic speeds is a mechanical suicide mission. The core physics problem of the armor is how the human inside survives the maneuver. Exceeding 12 Gs requires an internal biology management system capable of artificially maintaining pilot consciousness. In a typical military jet, a pilot wears a G-suit that squeezes their legs to force blood toward the brain. At 20 Gs, internal organs effectively become heavier. The heart sinks into the stomach, making leg compression useless. The armor addresses this with a neurovascular compression system. This is a subconscious G-suit managed by the onboard AI, constricting around the pilot's limbs with millisecond precision to reroute blood flow. The primary biological solution is a pressurized liquid oxygen suspension. Tony Stark floats in this fluid, which creates a hydrostatic buffer filling the gap between his body and the inner wall. By submerging the pilot, this fluid takes the crushing pressure of a 30 G turn and distributes it evenly across the skin. It acts as a full-body shock absorber, preventing point-load trauma to internal organs. Biology is only half the equation. The airframe must ensure the bolts and structural joints don't shear off under the same stress. The chassis integrates a system of gyroscopic bracing. Thousands of microrotors are embedded inside the mechanical joints, spinning at hundreds of thousands of revolutions per minute. These rotors generate artificial inertia. When the suit turns, these create enough counter-torque to lock the flexible armor into a single, rigid unit that fights off the incoming inertial shear. But constant high-G maneuvers invite actuator fatigue. If the stress of a tight turn creates a single microscopic hairline fracture in a hip servo, the structure is compromised. If that servo fails mid-turn, it triggers a vector mismatch. The suit loses aerodynamic stability and enters a supersonic tumble, where centrifugal forces rapidly spike to 50 Gs. At 50 Gs, the internal pressure overwhelms the seals. The buffer bursts, causing internal deceleration trauma. The pilot's momentum hurls them forward, crushing them against the titanium interior. The system operates on a razor-thin margin of safety. A single material crack turns the golden armor into a casket. The armor functions as a masterpiece of structural dampening. The suit represents the successful integration of a 2-ton metal cage and a biological nervous system, allowing a human to command and weaponize inertia. The pilot lives in the gap between high-speed maneuverability and catastrophic structural collapse. Executing a blind turn at these speeds requires absolute faith in the engineering. The pilot trusts the mathematics of those spinning microrotors more than his own mortality. The armor's definitive achievement is the complex engineering required to keep a human heart beating at the center of a supersonic hurricane.